Hello, class, and today we're going to be continuing on and looking at parallel lines. But first, let's start with this warm-up. So I'm going to take this and pop it right on down here, and we're going to be looking at some things. So, create something. So the warm-up is pretty simple. We've been looking at conditional statements for a while, so it should be pretty easy to create something from this. So we can either create a converse, inverse, contrapositive for any one of these conditions. So we're looking at the fact that the stone is wet. The stone is dry if it's raining. If the stone is dry, it's not raining. It's shadow on the ground, it's sunny, and etc. So go ahead and give it a pause and give that a shot. Okay, welcome back. So at this point, I'm just going to grab the laser pointer so you can have that. So have that, and we'll edit if need be. For instance, we could have just said the stone is not wet. That means it's not raining. That would be the inverse for that. So that was just a quick example. Let's continue on. So we're going to be spending 2 days in parallel lines, and then we're going to spend a couple days in triangle sums and go from there. So define parallel lines using undefined terms and points. Prove theorems about parallel lines and going from there. So we're going to have a warm-up, look at the vocab, have a quick little discussion, and have a break in classwork. So review for vocabularies, we have adjacent angles, linear pair, supplementary angles, and vertical angles. So we're going to have a look at those and make sure that all makes sense here soon. Okay, angle pairs. So for this, we're asking what pairs or angles map to which angles. In other words, if we were going to take these four angles and just move them down on top of the other ones, which one would they map to? You'll see that in a second. So as we do that, I'll do that a couple of times. You see that the 1 maps to the 6, the 2 maps to the 5, 4 maps to the 8, and that 3 maps to that 7. So it's just seeing if you're to pick them up and pop them down. Another way you can see it is like this 1 is in this corner, this 6 is in this corner. They share the same corner. The 2 and the 5, the 4 and the 8, the 3 and the 7. So we say that basically 1 goes to 6, which means 1's congruent to 6. 2 goes to 5, 2's congruent to 5. 3 just goes to 7, and 4 goes to 8. We just covered that, so it should make a little more sense at this point. All right. So, alternate interior angles. So which ones are interior here? Well, 3 and 5, 4 and 6. Those are our interior angles here. So the alternate interior would be the ones on the opposite sides, 3 and 6, 4 and 5. So they're kind of a pit of the Z. We'll see what we mean here in a second. So when we make the Z pattern, notice that 4 and 5 are in a pit of C. Those two would be congruent. Likewise, we can also say that 3 and 6 are also in the pit. So those two are congruent. So remember what congruent means in this case. Congruent means that they are identical, or basically close to being identical, or the same thing. As you can see, there's a little bit of an equal sign right here. So it's just a couple different ways to look at it. So another thing we'll be seeing at one point and go in more detail is alternate exterior angles, but we'll cover this in more detail tomorrow. So we have 1, 2, 8, and 7. So they're opposite as well. We have 1 and 7, and 2 and 8. Angle pairs. So notice the map of congruence. 1 maps to 6 because we first said that, hey, if we can pick up 1, same corner 6. But we know that 6, we can make that Z pattern to 3. But that 3 can also be in the same spot as that 7, which means that 7 maps all the way back to that 1 because the 7 and 1 are alternate exterior angles. So we have this pattern. We have a similar one for the ones that we have not covered here. So 2 would map down to 5, which makes the Z pattern to 4, maps down to 8. You can also say that 1 and 3 are connected because they're vertical angles. So 2, 4, 5 is the other root. So there's a lot of ways to look at this and say, hey, these are congruent. So we have several postulates, same side interior angle postulate. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. So supplementary means they sum up to 180 as seen down here. Measure 1 plus measure 2 is equal to 180. On the handout, you also have this basic information as well. We'll cover about that in a little bit. So let's go ahead and put it to work. So we have 1 highlighted, 2 highlighted. So we add them to 180. Example, same side interior angles. If measure of 2 is 123 degrees right here, label the rest. So we can see that 123 here, same vertical angle down to here. We can also do the Z pattern that's being traced right here for here and our vertical angle. Or we can say, hey, this and this are matched by corresponding angles. This maps down to here via vertical angle theorem, and that maps up to their corresponding angles. So if we subtract 123 from 180, we get 57, and that will just simply fill in the rest. So you see, once you get like one angle, it's pretty easy to get the rest, because you only really have 2 choices, especially if you're dealing with parallel lines only. So go ahead and give this a shot, and shouldn't be too hard. If measure 6, that's this one, is 99, you can, which ones are 99? All right. So give it a pause if you want, and we'll resume it soon. Welcome back. So if this one's 99, that means by vertical angles, this one's 99. By corresponding angle, or not corresponding angles, this one's 99, or alternate interior angles, this one's 99. Vertical angles, 99. Another 99 over here, 99, 99, 99. So we have 99 there. So if it's not labeled, it's 81 degrees. As you saw, we were able to kind of piece together which ones are 99, which one's 81. The other thing I've mentioned several times is the alternate interior angle theorem. If the transversal intersects two parallel lines, the alternate interior angles are congruent. That means they're equal. So remember the Z. So let's just go ahead and have a look. Example 1, use either theorem to figure out what it is. So we have the 4x minus 10 is equal to 58. So sometimes we might have to solve for an x, because we can see that this is that whole Z pattern. So we can go from there. And we add that 10 to both sides. So we'll go ahead and add that 10 to both sides here in a second, bringing down the equation and adding the 10 to there and over to the other side. So we'll be, by adding 10 to both sides, we are canceling the 10 on the left-hand side and adding it to the right. So we have 4x equals 68. Divide both sides by 4, and we get x is equal to 17. Not that bad. So we're going to assume that A and B are parallel. So using alternate interior angle theorems, we can find the value of the angle. Might be a little hard to see, so we're going to bring it right on down. 5x minus 54 and 3x plus 16. So we start by subtracting the 3x from both sides, because the quantity 3 is smaller than quantity 5, and we don't really want to deal with negative values, unless you really like negative values, but not many people do. So we have 2x minus 54 is 58, is equal to 16. We add the 54 to both sides. Then we get 2x is equal to 70. All right. Sorry about the call in the background. I will go take care of that. There we are. Okay, anyways. So we have 2x is equal to 70. Now we're just going to divide the 2 on both sides. So we get x is equal to 35. With the x is 35, we have to plug that 35 back in, and we'll see that we'll get the same exact equation, or same, not equation, but same exact value. 5 times 35 minus 54, 3 times 35 plus 16. So 5 times 35 is 175, so we're going to subtract 54. 3 times 35 is 105, we're adding 16. 121 degrees each time. Not that hard. So at this point, we're going to see this big stop sign. So what we're going to do is going to jump over to the other slide right here and have a look what's going on. As you see, I provided you some information, such as a transversal is a line that crosses the parallel lines. It's supposed to be not leans, it's supposed to be lines. So let's go and fix it. I'll have to fix that. So it's supposed to be lines. Sorry about that. So let's, so that's what it's supposed to be, not leans. It's supposed to be lines. And then congruent having the same measurement. And then we have supplementary angles. So that means they sum up to 180 degrees. Whenever you see this little indicating arrow thing like that, what that's actually saying is we have parallel lines, which means that this is the transversal line, that one that doesn't have that normally. But you might have a case where you have multiple parallel lines intersecting each other, like that one example. Okay, we also have the exteriors. And we have, let's just change this to a nice blue, the interiors. Okay. So, same side interior angles. As you see, we have the same side interior angles. The angles are aligned on the same side, as you see over here in this diagram. And they're all the same of the transversal right there. And they're basically on the inside of the parallel lines, as seen right here. And these are supplementary. If you come back up to the word supplementary, you see they add or sum to 180 degrees. Same side exterior. These are the same side of the transversal, but on the outside, these angles are also supplementary. So let's just go ahead and highlight the supplementary in red, just as an indicator, hey, that's slightly different. And we'll put this other one in blue. So the congruent ones we're going to put in blue. So alternate interior, the Z pattern, ink, ink, ink. So the Z pattern would be ink, ink, ink. So alternate interior angles are on opposite sides of the transversal and the inside of the parallel lines. Remember the Z, these angles are congruent. And then we have vertical angles. Angles that are across from one another, as you see here, are formed by intersecting lines. So the very important thing to realize is this is not limited to parallel lines and transversals. So anytime you have intersecting lines, this is true. So these lines are congruent. Okay, so let's go ahead and have a look at some of these structure problems. So structure problem. So if we're looking at this very first structure problem, we see that we have one here and one here. Looking at our key, we notice that it's the same side interior. So we can put that type of angular pair will be same side interior. Okay, so that means these angles are supplementary. So an x in this case, we have to just do a little bit of figuring out what x is. So we have x plus 120 equals 180. So what we're going to do is subtract the 120 from both sides. That gives us x is equal to 60. So x is equal to 60. Not that hard. So zoom out just a little bit and scroll down just a little bit so we can have a look at this next example. All right, example 2. If we look at it, we should see that we have that Z pattern. Like that. So what should that tell us? Alternate interior angles. also known as AIA. These angles are congruent. That also means that symbol. So what is x in this case? It's not exactly clear, so we just have to do quick figuring out. So 3x is going to be congruent to 72. So all we need to do is just divide by that 3. And we get x is equal, well, 3 divides 7 twice with 1 left over. So we'll have that 1 with that 12. Making that with that 2 making a 12, and 3 divides 12 4 times. So an x in this case equals 24. All right. So go ahead and give this a pause at this point, and go ahead and work on this one that's down here. And we'll resume working on it here in a little bit. All right. Welcome back. Yes, it has a fraction. Yes, people don't like fractions, but you have everything you need in order to solve this problem. Okay? So the first thing you want to realize is, hey, you have an angle there and an angle there. We scroll up, we realize that we have vertical angles. That means they're congruent. So this is a case of not the blue, vertical angles. That means these are congruent. All right. So to figure out what x is, all we need to do is take 1/4 of whatever x is and have that equal to 84. Remember, the name of this game is to get this x by itself. Right now, we are in a sense dividing by 4. So to get rid of division of 4, all we need to do is multiply by 4. So 4 times 1/4 just gets us an x. Now this is where it's going to be kind of a large number, but still it's going to work because we're really taking 1/4. And when we take 1/4 of it, we're still going to get this angle of 84. So 4 times 4 is 16. 4 times 8, well, 8 times 2, what's that? 8, 16. 16 times 2 is 32. So we're going to add that and get 33. So by adding that 1, so we have 3, 3, 6 is our x term. You might be saying, hey, 336 is a lot larger than 180, but remember, we're taking 1/4 of it, so it's going to reduce down to 84, which is less than 180, so it's still fine. So we need to make sure we have that straight. All right, so at this point, we're going to jump back over to here and continue on. So this is a bit of a challenge one. The alternate interior angle tells us what? That 2x is congruent to 42. So this one is congruent to 42, and that's all we need in order to solve this situation here. Since 2x is congruent to 42, we can divide both sides by 2. (8y plus 2). So we could do it that way, or just realize that we have this whole thing. Because these are congruent, we can substitute them in. So we don't need to simplify. We could divide by 2, but then we would have to multiply by 2, or just realize that these are both 42. So by realizing they're both 42, we can just plug it right on in. So then we have 8y plus 2 plus 42 is equal to 180. Simple. So now we're going to go ahead and simplify slightly. So the question will be, why did I do the following step? Notice up here, all I did was subtract the 42 from both sides to get to 138. So the question is, why did I do this step? So we're just trying to figure out what the angles are, right? I could have added the 42 and 42, but then I would have had to divide everything by 8. But if I know that this whole thing is equal to 138, I am done if it's not asking for what y is. So we know that that's 42, that's 138, that's 42, and that's 138. Notice we could have also used right here 42, 180 minus 42 would have gotten us 138, and then we could have said, okay, well, this is 42, 138, 42. A couple different ways to go through this problem. All right. With that said, there should be a handout coming to you guys at this point if you're in class, so you can see what we're going to be working on. What it looks like, if we jump back to here, is this. So you can list what type of angles are, or what the angle pair is, just to memorize to help you understand which ones are, the type of angles they are they congruent, or they equate. And we can write the equation and go through the angle measurement. So that's what we have here. So it shouldn't be too bad. All right. So with that said,